March 11, 2011 began as an ordinary day in Japan. Children in school, adults at work, life moving as usual. But deep beneath the Pacific, the Earth was about to unleash unimaginable power. Suddenly the ground roared and shook violently for 6 endless minutes, far longer than anyone was used to. Buildings in Tokyo swayed, roads cracked, and bridges strained under the force. This was a magnitude 9.1 earthquake, one of the strongest ever recorded. Yet the true disaster was just beginning. The quake, centered under the sea, displaced a massive volume of water, spawning a tsunami. Warnings came, but the waves were faster and larger than anyone expected, some as tall as 10-story buildings. The tsunami crashed over seawalls, sweeping away homes, cars, and entire neighborhoods. People ran for higher ground, but many were overtaken by the relentless water. The devastation was total. Schools, hospitals, and communities vanished in minutes. Survivors clung to rooftops and debris, waiting for rescue. The Tohoku earthquake and tsunami was a stark reminder, even in a world of technology, nature's power is absolute. In the aftermath, Japan faced unimaginable loss, but also showed resilience and unity. The world watched, learning hard lessons about preparedness and the limits of human control. The event shifted the planet's axis and changed countless lives forever. It was a day that redefined disaster for a generation. The memory of that day continues to shape how we prepare for the next big one. Nature's fury, once unleashed, leaves a mark that lasts for generations. Most earthquakes are small, but megaquakes are the planet's true giants. Defined as magnitude 9.0 or higher, each step up the scale means exponentially more energy, 32 times more for each whole number. A megaquake can last 5 minutes or more, shaking the ground so violently it feels like the world is coming apart. The energy released equals thousands of atomic bombs, sending seismic waves across entire countries. Buildings collapse, roads split, and the ground can even liquefy, swallowing everything above. Landslides and tsunamis often follow, compounding the destruction. Megaquakes are rare, striking only a few times each century, but their impact is global. They occur where tectonic plates collide and lock, storing energy for decades or centuries. When the plates finally slip, the result is catastrophic. Understanding these events is the first step to surviving them. Scientists study where and why megaquakes happen to help us prepare. The more we know, the better we can protect ourselves. Megaquakes remind us of the raw power beneath our feet. Only a handful of earthquakes in history have reached megaquake status. The most powerful, Chile 1960, was a magnitude 9.5. Its shaking and tsunami were felt across the Pacific. The 2004 Indian Ocean quake, magnitude 9.1, triggered a tsunami that killed over 230,000 people in 14 countries. Alaska's 1964 Good Friday quake, magnitude 9.2, devastated Anchorage and sent tsunamis down the North American coast. Japan's 2011 Tohoku quake and Russia's 1952 Kamchatka quake also make the list. Each event followed a similar pattern: massive shaking, followed by a deadly tsunami. All occurred where tectonic plates collide and one is forced beneath the other. Studying these disasters helps us spot patterns and prepare for future threats. The lessons learned have led to stronger buildings and better warning systems. History's megaquakes are warnings we cannot afford to ignore. Earth's surface is made of giant tectonic plates, slowly shifting atop a sea of molten rock. Where these plates meet, they can collide, pull apart, or slide past each other. Megaquakes happen at subduction zones, where one plate dives beneath another. The plates lock together, building up stress for decades or centuries. When the pressure finally breaks the lock, the plates slip suddenly, releasing massive energy as an earthquake. The longer the plates are stuck, the bigger the quake. In a megaquake, hundreds of kilometers of fault can rupture at once. The land can rise or fall by several meters in seconds. This sudden movement often lifts the seafloor, displacing water and creating tsunamis. The process reshapes coastlines and changes landscapes instantly. Understanding plate tectonics is key to predicting where megaquakes and tsunamis will strike. The link between subduction zones and disaster is clear. Our planet's restless crust is both creator and destroyer. The forces beneath us never truly rest. In 2011, Japan's Tohoku earthquake unleashed a tsunami that swept away entire towns. Hiromitsu Shinkawa survived by clinging to his roof for 2 days at sea, a story of luck and determination. In Fudai, a high seawall built by a cautious mayor saved the town, proving preparation pays off. These stories show the difference between luck and planning. Fast forward to 2023, a magnitude 7.1 quake struck off Sumatra. Remembering 2004's tragedy, Communities evacuated immediately, following drills and warnings. Sirens blared, texts were sent, and people moved to safety without hesitation. This time the tsunami was small, but the response was a success. Fisherman Booty said, "We felt the shake and we knew what to do. We ran." The difference: education, drills, and memory of past disasters. Preparedness turned potential tragedy into a story of resilience. Communities that learn from the past are far more likely to survive the next disaster. The lesson: knowledge and readiness save lives. Every warning, every drill matters. Tsunamis aren't like normal waves. They're born from sudden, massive shifts in the ocean floor. Most often, a megaquake at a subduction zone jolts the seafloor, pushing up a huge column of water. In deep ocean, a tsunami wave is barely noticeable, just a meter high but hundreds of kilometers long, racing as fast as a jet. As it nears shore, the wave slows and grows, rising into a towering wall of water. The first wave isn't always the biggest. Multiple waves can strike over hours. When a tsunami hits land, it's a fast-rising flood, not a single crashing wave. The water's force destroys buildings, uproots trees, and sweeps away everything in its path. The danger can last for hours as more waves arrive. Tsunamis carry the energy of the earthquake across entire oceans. Their power is relentless and unforgiving. Understanding how they form is crucial to survival. The Pacific Ring of Fire is a 40,000-kilometer horseshoe of seismic activity encircling the Pacific Ocean. Here, tectonic plates collide, making it the world's most earthquake and volcano-prone region. Countries like Japan, Indonesia, Chile, and the U.S. West Coast face constant risk. 90% of earthquakes and most volcanoes happen here. Subduction zones along the ring are hotspots for megaquakes and tsunamis. For millions living here, disaster preparedness is a way of life. Drills, strong buildings, and evacuation routes are standard. Scientists use sensors and satellites to monitor the region, searching for warning signs. While we can't predict quakes perfectly, we know where the greatest risks are. This knowledge shapes building codes and emergency plans. Living on the Ring of Fire means respecting the Earth's power. Preparation and vigilance are essential for survival. The Ring of Fire is both a threat and a teacher. After the 2004 tsunami, global warning systems became a priority. Seismometers instantly detect undersea quakes, pinpointing their size and location. Not every quake triggers a tsunami, so dart buoys, deep ocean sensors, confirm if a wave is forming. These sensors send real-time data to warning centers via satellite. Once a tsunami is confirmed, alerts go out through TV, radio, text messages, and coastal sirens. The goal: give people precious minutes to reach higher ground. Technology alone isn't enough. Community drills and education are vital. Regular evacuation drills teach people what to do when the warning comes. Signs mark escape routes, and emergency plans are in place for schools and hospitals. Prepared communities respond faster and save more lives. The combination of technology and practice is our best defense. Everyone has a role in staying safe. Knowing the warning signs and acting quickly can mean the difference between life and death. The world is better prepared than ever, but vigilance is key. Safety is a shared responsibility. After a megaquake and tsunami, the challenge is not just rebuilding structures, but lives. Communities come together, showing resilience and hope amid devastation. New buildings are stronger, sometimes relocated to higher ground. Mangrove forests are planted as natural barriers against future waves. The most important lesson: knowledge and preparation save lives. Recognize the warning signs. A strong quake or a sudden retreat of the sea means move to high ground immediately. Don't wait for official alerts, act fast. Have a disaster plan and emergency kit ready. Know your evacuation routes and help neighbors, especially the vulnerable. Drills and education empower people to respond instinctively. Every disaster is a chance to learn and improve. Understanding nature's power isn't about fear, it's about readiness. By preparing, we reduce risk and protect our communities. The human spirit is strongest when tested. Rebuilding is about more than recovery. It's about building a safer future. Knowledge and preparation are our greatest tools for survival.